Aloha, everyone. We're going to go ahead and get our next session started here. It's 10:30. My name is David Henderson. Thank you all for joining us for the Hawaii Department of Transportation's 2024 Protect Our Water Conference. I'll be your moderator for this session. Our session is titled Lahaina Wildfire Storm Water Mitigation Response. At the end of the presentation, we'll have a couple minutes for questions and answers. So we're going to go ahead and introduce our speaker for this session, Mr. Mark Ohigashi. He was born and raised in Honolulu and attended Loyola Marymount University, where he earned a Bachelor's of Science degree in Civil Engineering, and Stanford University, where he earned a Master's of Science degree in Civil Engineering, with a concentration on environmental engineering and science. While pursuing a career in medicine, he worked for the Los Angeles District of the U.S. Army Corps of Engineers in their construction division, managing renovation projects for the VA West LA campus. After a few years of working as a medical assistant, Mark was hired at Brown & Caldwell in Honolulu. And after almost 8 years at Brown & Caldwell, he left as an associate engineer to work as an environmental scientist at Hawaiian Electric in their air monitoring and noise compliance department. A licensed professional engineer in the state of Hawaii, Mark has over 15 years of experience in a breadth of civil, environmental engineering disciplines representing private, government, and utility entities. He is currently the engineering department manager in Enviro Services and Training Center. He specializes in site civil design, erosion and sediment control planning, municipal water pump station design, local and federal regulatory permitting, environmental planning, site hydrology assessment, wastewater, potable and reuse hydrologic design, oh my goodness, Mark, underground injection well regulatory compliance, government QA and QC, project management and construction management services. So please help me in welcoming Mark Ohigashi. Good morning.
Wow, after that introduction, I have no time left for this presentation. But thank you. I'm so happy to be here and so honored to share a little bit of some of our experiences that we as the Stormwater Management Program consultant for the State Highways Maui District to talk about this one tragedy and also the engineering work that we put into it to mitigate the stormwater running off into the ocean. So a little bit of an agenda. We'll go over the background leading up to our response. Talk a little bit about the scope and the challenges that we faced coming into this project. Talk a little bit about the approach and some of the goals that we had and the execution, and then finally the outcomes. And hopefully that will be a little bit eye-opening and yeah. All right. So a little bit of background. So the State Department of Transportation Highways Maui District manages the MS4 program under the NPDES. Particularly with Maui, the urbanized area, it's classified as an urbanized area, being that there are over 50,000 people in the census tracts, and again, this is kind of geographically defined in a dense area. So this includes Kahului, Wailuku to Waikapu, Wai'ehu to Paia. And that's kind of highlighted in that red. But, that being said, this is while it's a centralized area of Maui, it really encompasses the entire island because the Maui district wants to be able to, I guess, spread the good word and the good work that they do to the entire island. So the Stormwater Management Program describes the procedures, program activities, and best management practices complemented with respect to certain control measures. So they're basically held to these control measures that are addressed with different programs. Some of those programs are public education and outreach, public involvement, illicit discharge detection and elimination, and as part of that, the industrial and commercial facility inspections program, construction site runoff control, post-construction runoff control, and pollution prevention and good housekeeping. And under that is also the program handling erosion control. So now that you know the background of Enviro Services involvement in the stormwater management program for the state, this is what happened. Lahaina wildfire. Total devastation. And I will share a little bit of personal connection to this. My family is actually from Maui, although I grew up on Oahu. I kind of grew up on Front Street, going to visit the different shops. One of my aunties actually had a t-shirt shop, one street off of Front Street. Seeing this kind of devastation was a little bit of heartbreak for me, but it just made my resolve even stronger to address the issues that came from this wildfire. So on August 8th, 2023, that's when the fire happened, and it was driven by hurricane force winds coming off the coast. Even though it wasn't a direct hit, those winds did spread that fire across a wide geographic area. More than 2,200 structures were affected or completely destroyed, $5.5 billion in damages, and over 2,100 acres burned. And of course, what's unmeasurable and in terms of its worth is the 102 lives lost. But getting into the crux of our involvement, Lahaina town was really destroyed and littered with rubble, ash, and unknown hazardous materials along multiple roadways and under different jurisdictions. This photo was taken by our team out there in Lahaina, and you can kind of see while there's this impending rain, and it is raining because there's a rainbow, it really is a sign that things are going to get better. And so that is why our scope was to mitigate the impacts of runoff from the burn zone and protect the receiving waters from potentially hazardous materials and pollutants before the upcoming rainy season. It's just another photo, but you can see how impactful these sites were for our teams while we were out there. So part of it, there's a lot of challenges that once we were given charge of this project, that we encountered. One of them was really determining the storm water flow. And the challenges were really highlighted by the large watershed area that we're dealing with because it did involve pretty much the entire town. A very long shorefront discharge area with multiple outfalls, straight runoff, and so, we had to come up with a very comprehensive plan that would encompass all of these challenges. Particularly if you are aware of how stormwater flow is calculated, it's a very short flow path to discharge, and also a short time of concentration. So compared to other wildfires that have happened across the country, those happen in the mountains typically, or in geographic areas where there's a lot of time to intercept pollutants from stormwater. This is not the case in Lahaina. It was shorefront, and we really had to come up with a catch-all system and approach to making sure that pollutants didn't end up in the ocean. So you can see, yes, this is a very large geographic area outlined by the watershed that's outlined in orange. It really encompassed from the Lahaina Civic Center on the north, all the way down to Front Street Honopi'ilani Highway intersection on the south. Another challenge that we faced, as I kind of alluded to, is we were in a race against time. So the fire happened on August 3rd, but the approaching rainy season provided a challenge of time to us to put in something quickly. And as part of that, and conflicting with that, was understanding the drainage systems. We weren't just dealing with the highways divisions, drainage systems, the state's drainage systems. We were dealing with County of Maui systems as well. And, as part of that, we didn't understand all of what was actually out there. So, we had a consultant help us, a sub-consultant help us to do a condition assessment. And, they got out there really quickly and gave us an idea of what we could use to intercept all the pollutants that would potentially run off. One of the other challenges is that we had conflicting records from County of Maui drainage structures from what we actually observed out in the field. And so, when we're trying to figure out where water is going and how to intercept it, that provided a challenge. And as you can see, in order to fully understand the system, we had to get out there, but we also had to consider the safety of our staff while getting out there. So as you can see, we're fully dressed in PPE, respirators, and sometimes I think we're a little more prepared than some of the other consultants that were out there, or government entities that were out there in the field trying to do their assessments. Another challenge is that we didn't want to contribute to the problem. We don't want to add more chemicals. We don't want to get in the way. We don't want to, make the problem worse by, trying to get it better. So, part of that was not trampling on the cultural sites. So we were very careful to understand what the cultural impacts are of the work that we were doing. So, if we were going to put out interceptors or baskets or anything like that to address the pollutants, we didn't want to compromise these cultural sites that Lahaina is known for. And in part of that, we also didn't want to hinder access for the cleanup that was going on around us. So in the early part of the project, the question really came up, who is leading this effort? Is it the feds? Is it the state? Is it the county? But we all just wanted to do something. And so Highways Division actually took charge and, got moving and relatively quickly, within a month or so, and we started doing, implementing BMPs right away. So the actual treatment solutions that we proposed and implemented were multi-tiered. Basically, it's to remove the material, provide erosion control, and really catch everything on the perimeter of the burn area. As part of that, we also implemented inlet protection for the systems, existing systems, and we also came up with a very comprehensive catch-all engineering solution that could be deployed temporarily and not leave a lasting impact. So we're basically just implementing BMPs, and we're all here at this conference, and that's the buzzword, BMPs. But it really boils down to that. And as part of that, we implemented debris removal, and that was the easiest one to implement right away. So drain cleaning with vac trucks, street sweeping, and it was effective and quick. So 150 storm drains, structures were cleaned, 144 pipes cleaned, and approximately 12 and a half miles of roadways were swept. And there was a regular program implemented for this street sweeping. And as you can see, 100 tons of material were collected. Another layer that we implemented was erosion control. And part of that was coming up with ground stabilization material. And we evaluated quite a few different solutions. And one of them, getting back to the impact and not contributing to the problem, we wanted to find a product that could be applied to stabilize the soil without compromising the environmental health. And so we were able to find Flexterra, and this was applied to multiple areas across the burn zone to stabilize the soil that was now exposed due to the fire. And pictures speak 1,000 words. And you can see it implemented here. So all in all, 8.8 acres of exposed areas were covered by this Flexterra, and this is not including the soil stabilizers that were applied by the EPA to properties. And our next one is perimeter controls, and this is probably the most impactful one that we've implemented, and pretty easy to implement as well. And so, moving forward, I think this is something that can be used in future, knock on wood, hopefully future disasters like this. But we evaluated different materials and solutions to basically what could be deployed easily, what could be received quickly, and what was accessible, would provide access. And so some of the considerations that we took into the evaluation of this solution was access. If you were to put a sock down across a driveway and you're trying to provide access to cleanup crews, that would provide a problem. But because the sock is able to be moved relatively easy versus a different solution that was kind of hardened, that's a consideration we had to take. And then ease of installation. The Enviro socks were actually just able to be staked into the ground, into the pavement, and again, easily removed if need be by cleanup crews needing access. Another consideration was the advanced treatment that we looked into this product. And you can see the removal literature provided by the manufacturer. It addressed all different types of constituents that could possibly be in this pollutant runoff, from heavy metals to hydrocarbons to nutrients, as well as silt itself. And so that's really the end game for us in the choice of this product. Another thing was the availability. And so this product needed to be manufactured because there's not enough here on the islands. And so we took a look at how much they had here, how much could we get here, and could it be manufactured here? And it could actually be manufactured here, but because it's made out of the filter is made out of ground down pallets, there had to be a consideration of importing the sock from the mainland because of the rhinoceros beetle. And so that is what we took a look at. Luckily, they were able to manufacture it here with enough time. But at the same time, they actually supplemented this by manufacturing it on the mainland. Another consideration was the longevity of this product. This solution needed to be implemented for at least a year. And so based on literature provided by the manufacturer, they guaranteed that. It being a sock, it could be relatively easily replaced. So that was part of the consideration there. So this is showing the deployment and showing the results after a rain event. Very effective. But in the end, we deployed 36,000 linear feet of this Enviro socks, and it basically encompassed all of Front Street as well as Honopi'ilani Highway, the entire length through the town. We also implemented inlet protection, again, protecting the existing systems that were in place, whether that's the county or the state. we put these EnviroSocks around each drain inlet as well. And then if there were inlets in traffic areas, we put this other type of protection that could be driven upon. Again, pictures showing that it is effective. The last thing that we implemented or tried to design in parallel with all of these measures that we had taken was a capture and treatment system. And it was a temporary system that was designed, again, using the existing drainage infrastructure of the county as well as the state, and basically to catch it at the discharge points or right before the discharge points, pump it up to the top to a header, and all of that is transported and pumped to a receiving basin. And from there, the water would be treated and discharged. In the end, the system wasn't built because actually the county didn't want us to implement it because they had come up with their own solution. But I think it was a very robust system and a last resort kind of thing that we could have implemented and had gotten up to the point of construction. So in the end, there were great outcomes. Water quality measured at off the shores of Lahaina was clean, and to the point where the DOH allowed for entry back into those shores for recreation. And that's it. Any questions? I'm sure there are a lot. Yes.
So what did the county implement then?
I believe they actually ended up putting in their own inlet protection, perimeter controls, and basically took charge of Front Street again. And that's part of the challenge that we faced at the beginning of this project was to figure out who was going to do what. And so the State Department of Transportation actually took charge and was going to deploy all of these solutions on county infrastructure. But the county ended up catching up right before construction of that capture and convey system.
So it's going back into their system for treatment before being discharged, or?
I believe they're trying to catch any pollutants before it enters their system by implementing inlet protection. Yes, Jay.
Thank you. The filter socks,
Yes.
right? 36,000 lineal feet, is that what you said?
36,000
So
linear feet.
how long did that take for them to manufacture and then ship it to Maui?
Yeah, they manufactured it in a few months, but they sent over whatever they could, whatever they had in stock, and so, yeah, it was a kind of a ship and install process. Yeah, and as we moved along the length of the roadway.
And then if I could just ask one more question. Were there any samples taken other than what you showed to demonstrate the effectiveness? Even if it was just like turbidity or something like that for the different controls?
Yeah, so we actually did take a sample from one of the storm drains, and this was beyond the wattle that was already put out there. So when the state finally took over, I guess, this mitigation, they had already deployed, I think the county had already deployed wattles across different inlets. And so, yeah, we took a sample beyond it because, that's basically our baseline. And we sent it off for analysis. And we actually used that information to come up with a treatment system with that capture and convey. Yeah. But in situ in the ocean, that was sampled by others. Any other questions? No? Okay. Awesome. Thank you very much.